we've already talked about a tension force, and you imagine a tension force if I have two people pulling on a rope and one guy applies 10 newtons of force over here, then this other guy is going to feel that same 10 newtons of force. Assuming that your rope doesn't stretch, then you'll get that application of that tension throughout. And we're going to assume that that's true for our muscles too, and it generally is true, that the tension force is the same all along the muscle. So when you have that force at the point of origin that applies of 10 newtons, then you're going to get the same force at the insertion point. When we have our muscles moving, we have two different types of contractions. The isotonic contraction is a contraction of the muscle that causes the bone to move. Make sure you can identify these. I don't know the best way to memorize this. I think that I always think of like toning your muscles requires them to be moving around. I don't know, that's not really true. I mean, you can tone your muscles with isometric contractions too, but it helps me to remember that, toning your muscles, building your muscles, toning them requires movement. Isometric contraction does not cause motion. So you should try that right now. Do an isotonic contraction. Maybe you're flexing your biceps, moving your arm back and forth, and then you can do an isometric contraction where you're tensing your muscles, but not causing any motion. There are three different types of motion: the gliding, angular, and rotation. Um, the gliding motion was you have two flat bone surfaces that slide. And for example, you have this in your foot, in your hand. I think of that elsewhere, but foot and hand. Angular is the angle between the movable and immovable bones change. So an angular would be, well, like the arm right here, that if you move your bicep or if you move your lower arm back and forth, that's an angular type of movement. And then rotation, the bone twists along its long axis. We have a remarkable amount of angular movement in our body. The head is a good example, your hands, your feet, your wrist, your arm. So you have these different rotation movements. We're going to do these questions in the class, but you will need to identify the different classes of levers in the body. Just to remind you about the levers, this is a class 1 lever where my effort and resistance are on opposite sides of the axis of rotation. And then classes 2 and 3 look the same first, except for class 2, um, I would have my effort there and my resistance here. And for class 3, my resistance is there and my effort is there. So this is 1, 2, and 3. You'll have questions like here, for example, where you have to identify those on the test in the human body. And then I might also just give you some simple diagrams, but make sure you know these levers, classes of levers in the body. And then I will just say, remember too, that the class 3 requires a big force effort, whereas the class 2 requires a small force effort.